Hi, I'm Tim Spiller and I'm the Director of the Quantum Communications Hub. Now this video is to tell you a little bit about the Hub, what we've already achieved and what we're going to be doing in the next 5 years. So the Quantum Communications Hub is part of the UK National Quantum Technologies Programme, and it's one of 4 hubs that was established just over 5 years ago in order to start delivering new quantum technologies for the UK. So when the hubs were established and the UK programme was set up, we were briefed to take the outputs of the fundamental quantum science research that's been done in the UK over very many years, and for which we have an excellent track record, and to turn that basic quantum science into new technologies. So the way we went about doing that, I should explain that the Hub is a very large collaboration of many universities, the National Physical Laboratory, which is the UK's national measurement and test laboratory, and numerous industrial partners. So what we were tasked with doing was taking basic science and pushing it as far as we could take it through to new technologies. Now, in phase 1, most of the work that we pursued was based on quantum key distribution, or QKD. Now, QKD is a way of sharing cryptographic keys across distance by sending quantum light signals from one place to the other. And the key is guaranteed secure, because if anyone tries to tamper or measure the quantum light signals, then you can detect this tampering by the fact that the quantum light signals will be disturbed by people looking. So there is a guarantee of secure key distribution, because if anyone has a cheeky look at the distribution while it's underway, then you can detect that they've done so. So that's quantum key distribution. We took that basic science and we pushed it in 3 different directions in the last 5 years. So one thing we did is we built the UK's first quantum network. So that network is an optical fibre network around Cambridge and around Bristol, and it utilises links between the 2 cities. And we also have a link from Cambridge to British Telecom's research and development activity at a Adastral Park near Ipswich. So we've built and established, and we're now operating, the UK's first quantum network. Another aspect of QKD that we pursued in phase 1 was to look at short-range QKD transmission through free space, which meant you could establish a key shared between your phone and either a service provider or your bank or your employer over a short distance. And so we've developed the technologies that can deliver that short-range key distribution. We've also looked into establishing both the quantum transmitter and the quantum receiver on chip. And so in the future, these chips, which transmit and then receive the quantum light signals for key distribution, could be incorporated in all sorts of computers. So those are the 3 things we pursued during the last 5 years based on quantum key distribution. We also pursued some additional work going beyond key distribution into new technologies that, for example, could deliver quantum analogues of digital signatures and things like that. So that's what we've achieved so far. Now, during phase 1, a very important new aspect emerged for the UK National Quantum Technologies Programme, and that was the establishment of a quantum sector within the Industrial Strategy Challenge Fund. Now, that fund supports industry-led projects which are very much developmental focused in terms of turning demonstrators and things into real commercial products. And so now we have, if you like, an outlet or an exploitation route for the delivery of the hubs, in that we can transfer what we turn from the basic science into demonstrators and prototypes. We can transfer that into ISCF projects led by industry, and we've already got track record of doing that. So there are now various quantum-led industrial strategy challenge fund projects, and 2 of those are in the communications sector, and they have leveraged off the work that we've done in phase 1 of the hub and are now up and running, turning the technology into real commercial products. Okay, so now over to phase 2 of the UK National Quantum Technologies Project, because that started very recently and will run till 2024. So we've got 5 years ahead working on new stuff. The basic idea is exactly the same. We are still supposed to take basic science, the output of the quantum science research program in the UK, and turn that into prototypes, demonstrators, that can then be transferred into an ISCF project or transferred directly to industry, or perhaps a startup will be created that will exploit that new technology. So there are various exploitation routes, but our hub position is exactly the same. We're supposed to turn basic science into technology. So it's exactly the same as in phase 1. We have a very large collaboration consisting of a number of universities, again the National Physical Laboratory, and all the relevant industry partners that we need across the whole spectrum of work that we're going to deliver. So in phase 2, we're going to progress some of and continue with some of the work that we did in phase 1, and also undertake various new themes. And so in phase 2, we have in fact 8 parallel work streams, and I'll talk you through each one in just a minute. And we also have 3 cross-cutting activities that are relevant to all of those work streams. So in terms of what we are aiming to deliver in the next 5 years, the big headline message is that what we're after is quantum communications at all length scales. So that's our big goal, to deliver quantum communications across all distances. And so we're going to have various themes that will cover different aspects of that. And it's quite interesting that at the very shortest length scales, when you're talking from your phone to something that's nearby in the wall, in general you go through free space. You send a light signal through free space. Over more longer distances around cities and potentially between cities, one uses optical fibre, and so that's already available and in the ground, and we utilise existing optical fibre in our networking. And then the very longest distances, you go to free space again, because the only way to get between different continents or across oceans is to go from ground to satellite and back to ground again. And so we're going to be pursuing all of those in our phase 2. So the 8 parallel work streams that we've got, the first one of those is going to continue work with the UK Quantum Network. So as I explained already, we've established this network across the UK, fibre-based. We're sending quantum light signals around Cambridge and around Bristol, and from Cambridge to British Telecom and so on. We intend to further develop that network, add some new features to it, trial new applications on it, and in particular use it for user engagement. So we can demonstrate with our industrial partners just how this network will function and provide secure communications for their needs. So that's the first one. The next 2 work streams that we've got are looking at new methods of QKD. So we've got different ways of sending the quantum light signals. So at the minute we've basically been sending single photons, if you like, tiny quanta of light, but there are other ways to encode quantum signals into light, and we're going to look at sending quantum signals encoded into continuous light signals, which are more analogous to the standard optical quantum communications that people use. And we're also going to use this other fundamental quantum feature of entanglement, where there is an intimate link between 2 photons, 2 particles of light, and so we can utilize that to share quantum keys as well. And so we're going to be pursuing both of those as alternatives to ordinary single photon QKD transmission, and we're going to be looking at those both from the fibre-based perspective for networking, but also for free space. So in addition to that, we're going to further pursue our work on short-range QKD using, if you like, a transmitter in your phone and a receiver nearby. And we're also going to look at in-room QKD, if you like, from a source or a receiver that could be just mounted in the roof of a room, and talk to various computers in that room. So we're going to be pursuing short-distance QKD over free space. In addition to that, we've also going to be pursuing very long distance free space QKD, and that we're going to be looking at a satellite to ground transmission. So what we intend to do is we intend to put a quantum transmitter up on a CubeSat small satellite that can be launched relatively easily, and we're going to use that to send quantum signals down to a specialist quantum receiver that will be part of a ground station on the surface of the Earth. And so we're going to do QKD signaling between a satellite and a ground station on the Earth, basically to test out how that works, how efficient it can be made, and to learn about the best ways to do that with respect to future commercialization. So in addition to that, we're going to be pursuing also new work on chip-based quantum transmission and reception and various other chip-based applications. So we're going to be continuing with the chip scale QKD work. Two final work streams. One is to develop further protocols. So this is to go beyond key distribution and look at things, I mentioned already signatures, but also random number generation and possibly quantum tokens and things like that. So this is going beyond just sharing quantum keys, but implementing quantum security in other scenarios where other forms of quantum signal are used. The final aspect that we're pursuing, which is going to be relevant long term if there's going to be UK industry, is to develop components. So it's very important for quantum transmitters and receivers that you have the appropriate quantum sources and the highly sensitive quantum detectors that are needed in order to effect those transmissions. And so we're going to be working also on developing those specialist components that we need in the UK for quantum communications. So those are the 8 parallel work streams that we're going to be investigating in phase 2. In addition to that, we have 3 cross-cutting activities that we're going to pursue. The first of those is standards. So in any new technology scenario, the development of standards so that there can be agreement across industry about how to implement things, the development of standards is crucial. And so there's already significant activity in the quantum communications arena, developing new standards, and we've been instrumental in contributing to that in the last 5 years. We intend to do exactly the same over the next 5, because putting standards in place is going to be the way a real industry will emerge. So that's one very important cross-cutting activity that we intend to pursue. Another one is to combine quantum security with other aspects. So in the end, customers want solutions. They don't want technology that they then have to figure out how to use. They want solutions. And so we're going to look at incorporating quantum key distribution alongside new forms of mathematical crypto, so-called post-quantum cryptography. And so we can present the two together as a solution to provide secure communications for various scenarios. So we're going to be looking at integrating PQC with QKD in the various communication distance scales that I've referred to. So that's the second of those. The third one is clearly testing and security probing, because if we're going to produce secure communication systems, we'd better make sure that they actually work and do what they say. And so we'll be doing stress testing, and we'll be looking at the security of our systems from end to end. And that again is cross-cutting. It's across all of the different technologies that we're pursuing. So that pretty much covers everything that we're going to be doing in phase 2. I think we've got a good track record of delivery in phase 1, so we're looking very much forward to delivering all of these new technologies over the next 5 years. Thank you.